Hi everyone! In this video I'm going to explain how to figure out the domain and range of an integer function or an integer relation, determine whether or not that relation is a function, so really what a function is in its sort of basic definition sense, and then how you can actually express this relation or function, whatever you have, in a couple different notations, ordered pair notation or a mapping. So first of all, let's go through what domain and range mean. So domain is all of the x values that can exist for a relation. And so to figure that out, we're going to want to figure out all the x values that actually exist in this scatter plot. And then range is the exact same thing for your y values. What y values exist, in this case, on this scatter plot? So let's go through, let's just label all of our points. I guess I'll go from left to right. This point here is -7 and 5. This point here is -5 and -7. This point here is -2, -6, -2, -6. And this point here is -2, -2. This point here is 3, -4. This point here is 3, +4. This point here is 5, 1. And this is 7, 4. And finally, this is 10, 1. Now, I've listed all of these, of course, with the x coordinate first, because that's the standard way we write points. So the domain of this function, the domain is all possible values of x. And usually we just write d because from the context you can figure it out. And if you want to be fancy, you could put it in brace brackets. The brace brackets just mean it's the set of values. Whatever, not a big deal. But the listing the values of the domain, we'll just go from left to right. So we've got -7 is our first one. Our next x value is -5. The next x value we have data for is -2. Then we skip right over to 3, and then 5, and then 7, and then 10. And you'll notice, there's a couple of points here, like -2, -2 appear twice, but we only put it once in our domain, because either -2 is a permissible value for your x, it either is in your domain or it isn't. And you don't need to list it twice. And sorry, we should end with a brace bracket to match. And range is the exact same thing, except for y. So range is possible y values. And I guess we'll do R for that. So our range, I guess I'll go from bottom to top so that they're in order. So the lowest one I've got is over here at -7. My next highest point here is at -6. My next highest point is over here at -4. Then -2. Then 1. Then 4. And then finally 5 is our highest point. And so there is the range of our function. Okay, so those are the only values that are allowed. You can't have 0 for our domain or our range. It's just there's no point on our y-axis and there's no point on our x-axis. So that just doesn't exist. But this doesn't actually tell you what the function is, what the relation is. What is the mapping between these functions? If I have -7 for x, do I get -7 for y? Maybe, but this domain and range doesn't tell us that. So we need some other way of representing this actual function. So one way we create this function, I'll use f of x for our function just to be fancy. That just means that it's a function that maps our x values to something else. But anyway, notation aside, our function then can be a set of points. And I guess I'll go from left to right again. So I'm just going to list all of our points, -7, 5. And then my next is -5, -7. And then my next is -2, -6. And then -2, -2, and 3, -4, and 3, +4, and 5, 1, 7, 4, and 10, 1. And so that set of points is our function. And I suppose we could throw that in a brace bracket if we want to show that it's a set of values. Whatever, I don't really care. The point is, you understand that set of points is our function, is our relation, I should say, between these different points. And actually, maybe I should talk about this idea of whether or not this is a function. I sort of jumped right into function notation, but I probably shouldn't have, and this is why. Right here, we've got two different y values for the same x value. And so can you actually sub a single x value in and get a specific y value? So this is what this function notation means. The function notation means if you put a value in for x, you're going to get a specific value out for y. But in this case, if I know that x is 3, y could be -4, or y could be +4. So this actually isn't an x at all. Oh, okay, I shouldn't use function notation at all. So let's call this our relation. A relation is this set of points, okay? Because it's actually not a function, because it fails what's called the vertical line test. And it fails over here too. Here we also have 2 points on the same vertical line. And so that means that if x is -2, we don't know what y is. Y could be -2 or -6. Okay, so that's one notation. That is our ordered pairs, right? All of your points listed. But this idea of having like a uniqueness, like one x value going to a single y value, I think is actually best shown with something called a mapping. So I'm going to use these points, and I'm going to figure out my mapping based on these points. So here's what we're going to do. We're going to draw our x's on one side, and we're going to draw our y's on the other. And we can get these from our domain. So our x is going to be -7, -5, -2, 3, 5, 7, and 10, right? -2, -3, 5, 7, 10. And our range is -7, -6, -4, -2, 1, 4, 5. -2, and then 1, 4, 5. Okay, so now what I'm going to do is I'm actually going to describe this relation by showing arrows going from each x value to the y value it goes to. So -7 on the x-axis goes to 5 on the y-axis. So I can draw an arrow across for that mapping. -5 goes to -7. -5 goes to -7. -2 goes to -6. -2 goes to -6. -2 also goes to -2. 3 goes to -4. 3 goes to +4 as well. 5 goes to 1. 7 goes to 4. And 10 also goes to 1. And so this allows us to see sort of visually that these two x values go to multiple y values, and these two y values have two different x values that get to them. And so this is our mapping between the two, and this is our ordered pairs notation. And then the other way you can show it is what we started with, which is a graph. And those are sort of the three ways that you would generally show an integer function like this, or an integer relation. I keep using the word function when I mean relation. Sorry about that. An integer relation like this.